Hello guys, this is Ruben Raj and I'm going to teach you about the neural networks in the whole series. And in this first lesson, I'm going to talk briefly about the basic and important components which are required for the neural network. And these are all the references for the images and the other contents which I have used for this tutorial. And before getting into the topic, I want you guys to know that I'm not going to teach much on mathematical stuff. Instead, I'm going to show everything as a demo using Python. Yeah, that's all for the introduction. Now we can see the basic components and the important components for the neural network. So these are all the important components for neural network. The first one is neurons. Yes, and the second one is the layers in the neural network and the types of layers, and the third one is weights, and the fourth one is activation functions. We can see all these four one by one. The first one is neurons. The neurons are nothing but simple individual components which takes some input from the external source. It could be anything and it processes the input using some functions, and it produces the output. So how they got this name neuron for this neural network? So they got this overall idea from the human brains. We can consider the human brain, and the human brain contains 100 billions of neurons. For example, if a human want to do something, if a human want to classify something, for example, human sees peoples, and they have to classify the peoples who are all males and who are all females. Let's say this part of your brain will be responsible for classifying the peoples. So whenever you are giving some instruction to your brain, hey, classify the people, I want to know whether it's a female or male. So this part of the brain will be triggered, and all neurons in this part will be communicated from the previous knowledge, and it will find whether it's a male or female, and it will give you the result as output. So the same thing we are going to do in the neural network using the same structure, neurons, layers, and the communication between the neurons and everything. Yeah. So this is about these neurons. So simply you can consider neuron is a single individual component like we have in our brain, and it will take some input or instructions from the external source, and it will pass those inputs to there are many layers. It will pass to all other neurons, and it will do the operation, and it will give you the result. So this is all about neurons. And the layers in neural networks. So what are all the new layers? So what is layers? So typically we can take a very simple example to understand what is layers. You can see this burger. It have lot of stuffs in between these two breads. You can consider these stuffs as the layers. You can consider this meat as a meat layer, and cheese layer, and vegetable layer, and there are a lot of layers going on between these two breads. So the same thing is, the same kind of structure we are going to have in our neural network. And you can see this simple network. Here we have 3 layers. You have to consider this as an input layer, and the hidden layer, and the output layer. So this is just a simple network. It will not always be the case like this. For example, there should be one input layer to give the inputs. There should be one output layer, but there can be any number of hidden layers with any number of hidden neurons. We can have a look at a bigger example. This is not so bigger, but bigger than the previous one. So here you can see there are one input layer with 6 neurons, and there are 2 hidden layers, and the first hidden layer with 4 neurons, and the second hidden layer with 3 neurons, and there is one output layer with 1 output neuron. And we are also seeing there are connections going on between neurons, and these connections are called synaptic links, and each synaptic links are tagged with some weights. What is weight now? So the weight is nothing but a scalar number that each synaptic lines have, and the weights represent the you can say how strong the neurons are connected and how the inputs are mapped to the hidden layer neurons on the output layer. Next component in the list is weights, and the weight, you can consider the weights are nothing but a scalar value which is tagged to each synaptic lines. So each synaptic lines have their own weights, and the weights can be updated updated in each iteration. We will see that in the training. But so far what we have learned is we have learned what are the neurons and what is neurons, and how it's connected on the layers in the neural network, and the weights. The weights are nothing but the scalar value which is tagged with the synaptic links. Activation function is the last component in our list, and why we need activation function in neural network and what activation function really do in neural network. So the name itself implies that the activation function, which helps to activate something, it triggers, it activates the neuron. But how it will activate depends on some threshold value, or depends on the nature of the activation function itself. If I talk about activation function, it's not a single function or it's a single parameter we are going to use always. The activation function, there are many types of activation functions out there. For example, in this lesson I am going to use sine activation function, and I'll explain what is sine activation function now. So the sine activation function is nothing but it will take a number as an input. It could be positive number, it could be negative number. But how it will respond? If you give a positive number, you will always get +1 as a response, and if you give a negative number, you will get -1 always. You could see that in the graph. This is the positive region and this is the negative region of x coordinates. Let's say if your input is 0.5, it's a positive number, you will get 1 as a response. So for all the numbers in the positive region, you will get +1 as a response. For all the numbers in the negative region, you will get -1 as a response. So to show this as a demo, I have created a function called sine, and I'll pass the values here in the x variable. It could be positive or negative. So if the number is positive, you will get it, this function will return 1. If the given number is negative, this function will return -1. So for example, you can see here we are going to pass this 1.5 to the sine function, and we are going to execute that. So it returns 1 because the sine function will return 1 for the positive numbers. And if I give -1.5 here, let's say I chose this number -1.5, and I'm going to pass this -1.5 to the sine function, and now it will return -1. So this is the nature of this sine function. So now consider we are going to insert this sine function to all neurons in the hidden layer. So now all the neurons in the hidden layer will behave like a sine function. So whenever there is a input comes into the neuron, it will check whether the given number is a positive or negative. If it's a positive, it returns +1. If the given number is -1, it returns -1. I mean, if the given input is negative number, the hidden neuron will return -1 always. So this is all about activation function, but there are a lot of activation functions. Not only it returns +1 or -1. There are many activation functions returns values between some ranges. But now consider this is a basic introduction class. So just consider this sine function. And what are all the applications for neural networks? We can use neural networks for face recognition and handwritten character recognition, and we can predict weather, we can predict stock market, and there are many more applications for neural network. And at last, there is no demo for this lesson. Sorry for that, because it's an introduction. So so first, as a beginner, you should know about the components as theoretically. You could consider that. So from the next lesson, I will show the demo for what we have discussed from lesson 1, and also the next lesson I will show the real demo using a sine function. I'll show you how to construct a basic neural network with sine function, and we could also classify male or female. We could take up an example like that. So in the next lesson we will see how to classify males and females from the given points using a sine function. So that's all for today's class. We can quickly recap what we have learned. So we have seen neurons, how neuron works. Yes, neuron, it's an individual block which takes some input, process it, and it will give response like our brain neurons do. And the second one is we have seen the layers in the neural network. We have seen input layer, hidden layer, and the output layer. And the third component is weights. We have seen what is weights. The weights are a scalar number which is tagged with the synaptic links. And finally we have seen activation function, why we need activation functions, and how activation function works. Yes, that's all for today's class, and in the next lesson I will show you a demo how to classify males and females. Yeah, thank you guys. If you have any questions or queries or something, you can post them in comments. See you guys. Bye bye.